Hi, everybody. I am Roberto Polli from the Digital Transformation Department of Italy. And today I will present you a machine-readable semantic approach to schema design. After a brief recap on semantics, we'll show the different perspective of semantic experts and software architects with respect to API design, together with the importance of syntax in schema definition. Finally, we will present how to use OpenAPI to attach semantic information to REST APIs. The Italian digital strategy wants to uniform the APIs produced by thousands of agencies. All those APIs need to be semantically interoperable. That means that they must be based on a well-defined set of common concepts. But what's semantics? Semantics is the study of meaning and ensures that a message is understood. Here we have an ambiguous API message. We don't know the family name of this Fabiano Romildo, nor the currency used for his salary. We cannot mash up APIs with different formats and meanings. So, controlled vocabularies are a computer science tool that uses URI for disambiguating terms. Terms are identified by URIs prefixed with the vocabulary name, which provides a namespace. In these slides, we can see that the definition of dog from the DBpedia vocabulary is that a dog is a four-legged animal. But, well, we can say more. An ontology is a special vocabulary that describes a specific field of knowledge using a formal resource description framework. Here you can see a very small ontologies related to the dog term. From this, we learn that dog is a class of entities, and that is a subclass of another class, of another group of entities that is named memo. And memo is already a class of entities, and it is a subclass of animal that is disjoint from the class of fishes. We have another information here that dogs have a pet name property. So in this way, we have a formal language to represent knowledge. Ontologies are created by people focused on describing knowledge, that are semantic experts. Ontologies are focused on knowledge, not on implementation. And they aim at doing something like inference. That is, from here we know that a dog is an animal, but not a fish, and it has a name property, for example. And the resource description framework data model is based on graph. Here we have a simple representation of this ontology. We can see that dog is a mammal, that is an animal, but not a fish. A fish is an animal. And dog has a pet name, and the pet name is a property in the domain of dogs. Well, API designers are focused on data and operation, balancing expressivity and non-functional requirements such as security and performance. This is a different focus from semantic experts, which are focused on knowledge. So machine-readable semantics is not considered as key from the perspective of API designers, and semantic technologies are perceived as unnecessarily complex. Moreover, tools used by IT architects and semantic experts are significantly different with a very little intersection, like you can see from the graph below. Semantic information is specified in PDF files or out-of-band documents, and at best, it is expressed in prose into OpenAPI documents, for example, in summary or description. From a domain-driven perspective, API designers focus on dynamic bounded context, such as data, schema, input and outputs, while semantic web experts focus on the domain. Semantic experts study a specific field of interest to describe entities and relationships in their essence, like in the classical notion of ontology coming from Greek philosophy, and not necessarily by their behavior. Ontologies are great tools to support the definition of a domain model and bounded context, but they focus on the domain. To fit the solution space, they should be adapted to specific business cases and lose their genericity. For example, a data schema automatically generated from an ontological class can be suboptimal with respect to non-functional requirements, such as performances or constraints imposed by the technical architecture, such as field length or supported character set. JSON-LD is a W3C specification that bridges the gap between semantic and API experts. It allows to interpret JSON and RDF, adding context information. Here, we reference a default vocabulary. We associate a well-defined term to each property in blue. For example, name is mapped to the given name, schema.org given name ontological property. And we can even add a base URI so that the euro currency string here can be interpreted as a URI using this base. So schema.org is a minimal vocabulary balancing semantics and technical needs for providing semantic contents on the web. It is very simple and it does not fit complex use cases like public sector digital services. As you can see, attaching semantics to each message increases processing complexity and the size of exchanges. And you still need other technologies such as JSON schema for syntax definition. So, semantic web technologies are not optimized for syntax. RDF classes are for classification, not implementation. Semantic types are not always data types. For example, dog is a class, but it may not have a data type associated. RDF modeling is based on graph, while JSON and XML model are simple trees that's more efficient when it comes to programming. Semantic constraints, like we saw the disjoint between mammals and fishes, are semantic constraints that are meant for logical reasoning, not for constraining syntax. There are tools like shape constraint language that helps with syntax, but API developers consider them overly complex and computationally intensive. For all those reasons and more, there is no native support for semantic technologies from commercial off-the-shelf code generators, development frameworks, and API gateways. So let's come to our proposal. We propose to use different tools for different goals. Let's use ontologies to describe the problem space and the field of interest, and to support the creation of a domain model. Then, use OpenAPI to define the solution space, including schemas. Design schemas taking into account expressivity and efficiency, together with the domain knowledge contained in ontologies. Then, reference in the OpenAPI schemas, or the JSON schemas, all the ontological classes and properties that apply, so that consumers do not need to interpret out-of-band documentation or prose. In this way, schemas can evolve together with the business needs, without impacting on the design of ontologies. As the domain grows, the solution space can adapt to a wider problem space. For example, a schema can reference different ontologies. To support this view, we published the REST API linked data keywords internet draft. It is a very simple document. This specification allows to reference semantic concepts in OpenAPI using X keywords compatible with OpenAPI 3 and based on JSON linked data, JSON-LD. You can use it to describe in a single OpenAPI document both the syntax and the semantics of an API content, so that producers and consumers can agree on semantics at design time. It is easy, even for non-semantic experts, and it has a low implementation complexity. So, REST API linked data keywords in practice. Using this specification is trivial, since you just need to annotate the schema with a couple of keywords. While we recommend an accurate schema design that takes into account existing ontologies, you can even start from an existing schema. The first step is providing the RDF type, that is the ontological class, using the XJSON-LD type. As we saw before, your schema can use different property names than the RDF class, and the designers are responsible for the alignment between syntax and semantics using the specification. Mapping is based on JSON-LD specification for interpreting JSON as resource description framework resources. The XJSON-LD context here provides the context information we saw before for mapping JSON properties to RDF properties. Here we're mapping the name JSON schema property to the given name person property, and the surname to the family name. As you can see here, what we did for country, specific properties can reference different vocabularies. Here we are referencing the European Union vocabulary for countries to ensure that we have a well-defined country reference from this three-letter identifier. I want to clarify here that this is not a theory of everything unifying JSON schema and JSON-LD. In my opinion, this is not possible because those technologies have different goals and have been designed more than a bunch of years ago to address different goals. And they are widely deployed. There are libraries and so on. So the goal here is to be able to correlate JSON-LD and JSON schema from the perspective that JSON schema is related to the solution space of an API implementation, while the ontologies are related to this description of the problem space. Another point to remark is that not all RDF resources can be expressed as JSON documents annotated with context and type, but this can be improved in time into the JSON-LD specification. We do not profile JSON-LD specification in this document. So the features will improve in time thanks to the improvements that will be implemented in JSON-LD and in JSON schema. So the advantages. An implementation can use this semantic information at design time to reference the right properties starting from an ontology or discovering a code list, just like the European vocabulary for countries. It can be used at development or mashup time to verify that different APIs can be integrated consistently. In some specific cases, it can even be used at runtime to implement further workflows to verify the correctness of information without relying on people reading text documents. And another interesting point is that it can be used by catalogs to ensure that API design is consistent within a given ecosystem. In Italy, we are working specifically on this last point. In this slide, you can see a semantic API editor based on Swagger editor that we are studying. And as you can see, when you specify the ontological type, the ontological class of an object, it shows you the ontological properties so that those can be used to improve the design of the schema. And well, as you can see again, the property names in the JSON schema are different from the one that are provided in the ontology. They are just a subset of all the properties defined on the ontological class. So this is my last slide. You can find further information on the IETF website or on the repository for the draft. We provided, we link here the preliminary white paper and a EuroPython presentation. We are really interested in getting feedback on this specification. You are welcome to file issues on the repository if you want. So thank you to the OpenAPI specification conference for this opportunity to present you this work, and have a nice day. Bye.